Hello dear students, welcome back in this video lecture series. Dear friends, we are discussing the chemistry of many group elements, and today our topic is the chemistry of boron group elements. We know that boron group elements are belonging to the P block and 13th group of the periodic table. Okay, so if this is the rough diagram of a periodic table, then okay, so if this is the rough diagram of periodic table, we know that this is a S block, this is the central D block elements. On the right hand side of the periodic table it is P block elements, and at the bottom the two series are there and we call them as a F block elements, that is lanthanides and actinides. So this boron group elements is 13 group. So this is group number 1, 2, then 3 to 12. 3 to 12 corresponds to D block elements, and this is the 13 group element, and 13 group is the first group of P block. Okay, and at this place, this is the place of boron group elements. So boron is the first member of his family. So that's why these elements are known by its name. Okay, and hence these elements are known as boron group elements. These are boron having atomic number 5, then aluminium atomic number 13, then gallium atomic number 31, then indium atomic number 49, and thallium atomic number 81. Okay, so these boron, aluminium, gallium, indium and thallium, these 5 elements are belonging to the 13 group, that is boron group of members, boron group of elements. Okay, so when we are discussing the chemistry of these boron group elements, the first member of his family, that is boron, the properties of boron and other elements are strikingly different. Okay, so all chemical properties of the boron, first member of its family, and the remaining its member, they are differing strikingly from each other. Okay, so that's why the chemistry of boron is studied separately than the chemistry of remaining elements. Okay, so we will study first of all the chemistry of boron. Boron is forming large number of compounds, and mainly it is forming hydrides. So that's why our first topic is boron hydrides. Boron hydrides. So what are boron hydrides? Boron hydrides are the binary compounds of boron and hydrogen. These are binary compounds of boron and hydrogen. Binary means they are consisting of only 2 elements. One is boron and another is hydrogen. So these binary compounds formed by the combination of boron and hydrogen, they are called boron hydrides. We know that meaning of hydride. Okay, so these boron hydrides are either neutral, or anionic in nature. Anionic in nature. So they may be neutral or they may be anionic. Okay, so this is the form of these boron hydrides, and these boron hydrides are electron deficient. These are electron deficient in nature. As these are electron deficient in nature, so that's why they can be treated as, or they can be act as Levi's acids. Levi's acids. We know the definition of acids and bases on the basis of Levi's theory. So what is Levi's acids? So these are the electron deficient molecules or ions or compounds. Okay, so they have lack of electrons. They are deficient electron. They are electronically deficient. Okay, such compounds or ions we call them as a Levi's acids. They can easily react with the electron rich centers. Okay, so that's why as this is electron deficient, these boron hydrides are electron deficient, so they can be act as Levi's acids. Okay, now our most important point of discussion is the structure of these boron hydrides. Structures of these boron hydrides, that is structure and bonding. Structure and bonding of boron hydrides. The most important example and the famous example of this boron hydride is diborane. So diborane means there are two boron atoms in this molecule, hence its molecular formula is B2H6, diborane, B2H6. Okay, so actually BS3 is the BS3, we call this BS3 molecule as a borane. We call this BH3 molecule, boron hydride, as a borane, and as this is a dimer of this borane, so that's why we call it as a diborane. So BS3 into 2, it is giving B2H6, diborane. Okay, and because this borane is not existing at all, the existence of borane, that is boron hydride, is not exist in the nature at room temperature. So which is existing? So its dimer, that is B2H6, is existing at the room temperature in the gas form. Okay, so that's why generally we call it as a diborane instead of borane. Okay, so we have to discuss the structure of this diborane. Okay, so this diborane is having the structure like this. There are two boron atoms, and to each boron the hydrogen atoms are attached terminally. Hydrogen atoms are attached terminally. Okay, so these are two BH2 units, as well as along with this there is a presence of bridge protons or bridge hydrogen atoms are there in between the two boron atoms. Okay, so these two BH2 units, this one and this one, they are joined together by these bridged hydrogen atoms. Okay, so we can label that these are terminal hydrogen atoms, and these are also terminal, and this one and this one, they are called as bridged hydrogens. Okay, and in the similar way the bonds between this boron and hydrogen terminally, these are called terminal BH bonds, and these bonds BHB, these bonds are called as bridged bonds. Okay, now let us see here. So how it is the how we can explain the structure and bonding in this diborane. Okay, so the number of atoms present in this diborane are 8. Okay, so 2 boron and 6 hydrogen, so number of atoms is equal to 8. Okay, and number of electrons are only 12. So only 12 number of electrons are present in this diborane molecule. So that's why to accommodate or to bind these 8 atoms together properly, to bind these 8 atoms together properly, we require at least 14 electrons. We are requiring at least 14 electrons. If we have to write the correct structure of this diborane molecule according to Levi structure, okay, so to draw Levi structure, of this diborane, which is having 8 atoms, we must require at least 14 electrons. At least 14 electrons we must have to draw the Levi structure of this diborane, but we only have 12 electrons. So that's why we are 2 electrons deficient in this compound. We are having deficiency of 2 electrons. Okay, so that's why due to the deficiency of these 2 electrons, such molecules are called as Levi's acids, and they can act as electron deficient compounds. Okay, now the electrons contributed by the boron atoms and electrons contributed by the hydrogen atoms. Okay, so the terminal bonds, so how these 12 electrons present? So terminal bonds are terminal BH bonds. Terminal BH bonds, how many are there? 1, 2, 3 and 4. 4 BH bonds are there. So 4 bonds into 2 electrons. So each bond is having 2 electron. So 4 into 2, they are having total 8 electrons. And in addition to that, we have 2 bridged bonds. 2 bridged bonds. Okay, so these bridge bonds are Bhb bonds. Bhb bonds. This is one and this is second. Okay, so these are called 3 center 2 electron bond. These are called 3 center 2 electron bonds. Okay, and terminal bonds are called as 2 center 2 electron bonds. 2 centers means there are only 2 atoms. 1, 2 centers, and the 2 centers are having 2 electrons. This is also 2 center 2 electron bonds. So we have 4 2 center 2 electron bonds and 2 bridged bonds are there. They are called 3 center 2 electron bonds. 3 center means 1, 2, 3. There are 3 atoms are there and they are comprising of only 2 electrons. So that's why they are called 3 center 2 electron bonds. Okay, 3 center 2 electron bonds. Okay, they are also called bridged bonds. How many are they? They are 2 bonds. But these 3 center or bridged bonds are comprising of only 2 electrons. Okay, so 2 into 2, they are having 4 electrons. Okay, so this 8 electrons plus 4 electrons, we are having 12 electrons. This 8 plus 4, we are having only 12 electrons. Means this molecule is electronically deficient, and hence we should require 14 electrons to bind these 8 atoms together as per the Levi structure. Okay, so that's why this diborane molecule can be act as electron deficient compound. The interesting thing is that the 3 center 2 electron bonds is also called as banana bond. Is also called as banana type of bond. This is the special name for this 3 center 2 electron bond. They are called as banana bond. Okay, so the explanation of this 3 center and 2 electron bond, that is banana bond, is given by the molecular orbital theory, that is MOT. So MOT is explaining the structure and bonding, how the bridged bonds, that is banana bonds, that is 3 center 2 electron bonds, are formed in the case of diborane molecule. Okay, so MOT, we know the basis of this MOT. As per MOT, molecular orbital theory, the atomic orbitals combine together and they are forming molecular orbitals. They are forming molecular orbitals. So which atomic orbitals are there? So there are 2 elements are there. So 2 boron and 6 hydrogen atoms are there. We know the atomic number of boron, it is having 5. So its electronic configuration is 1s2, 2s2, 2p1. Okay, so there is only one s orbital and there are 3 p orbitals. Okay, and it is having only one electron in p subshell. So how many orbitals are contributed by boron? 1, 2, 3, 4. So each boron is contributing 4 orbitals. Each boron is contributing 4 orbitals, and as there are 2 boron atoms, so 2 into 4 is equal to 8 orbitals. Okay, so boron is contributing 8 orbitals. Now how many hydrogen atoms are there? Hydrogen atomic number 1, it is having only 1s1 electronic configuration, that is this electron is present in 1s atomic orbital. Okay, so as there are 6 hydrogen atoms, so we have 6 into 1, 6 into 1 is equal to 6 orbitals. So these are contributed by hydrogen and these 8 orbitals are contributed by 2 boron atoms. Okay, so sorry, 6 into 1, 6. So 8 plus 6, 14 orbitals. So we have 14 atomic orbitals. In and total, we have 14 atomic orbitals contributed by the 2 boron and 6 hydrogen atoms. So this is 14 atomic orbitals combines together, and there is a formation of molecular orbitals. Out of these 14 molecular orbitals, because as per the rule of MOT, we know that number of molecular orbitals formed are exactly equal to the number of atomic orbitals combined. Okay, so as per this rule, these 14 molecular orbitals are either either BMO or NBMO, that is bonding molecular orbital or non-bonding molecular orbital, and 7 must be anti-bonding molecular orbital. Out of 14 molecular orbitals that are formed, 7 must be either BMO or NBMO, and 7 must be anti-bonding molecular orbital, that is ABMO. Okay, now these 14 molecular orbitals are responsible to accommodate these 12 electrons present in this diborane molecule. Okay, now so we have to explain this Bhb bonds, that is 3 center 2 electron bonds, and MOT is explaining that these Bhb bonds are formed by the combination of one boron molecular atomic orbital, one boron atomic orbital, boron atomic orbitals, plus one s atomic orbital of hydrogen, and another again one boron atomic orbital. Okay, so 3 atomic orbitals they are combining. 3 atomic orbitals are combining. This is from boron, this is also from boron, and the 1s atomic orbital from the central or bridged hydrogen atoms. Okay, so 3 atomic orbitals they are combining together and they are forming a special type of orbital. We call that orbital as a bridge or midway between atomic orbitals and molecular orbitals. Okay, means such molecular orbital is formed that is not exactly atomic orbital or that is not exactly molecular orbital. Okay, such molecular orbital is formed and the shape of that molecular orbital is like this. So this is boron atomic orbital. So this portion is corresponds to boron. Then the central hydrogen, and again the boron. Okay, so this is boron, this is hydrogen, and this is also boron. Okay, such type of molecular orbital is formed that is not exactly atomic orbital, that is not exactly molecular orbital, or it is, we can say that it is in between the AO or MO. Okay, so this is the region of overlapping, where two electrons are present. So we have three center, 1, 2, 3, but electrons are only 2. Okay, so such type of bonds are called as 3 center 2 electron bonds or bridged bonds, and the molecular orbital form can be explained on the basis of MOT. Okay, and for writing such structure we may written like this: B, this is also boron, and the shape of that, the terminal atoms, hydrogen atoms, are written as it is. But to understand the meaning of that bridged hydrogen atoms or bridged bonds, we may write that this is the shape of that molecular orbital that is formed between two boron and hydrogen atoms. Okay, so this shape is looking like a banana. And hence such bonds are called as banana bonds. Okay, they are weak bonds as compared to terminal BH bonds. They are weak bonds. Okay, and hence less amount of energy are required to break such bonds, and hence when we supplied energy to this diborane molecule, it is immediately cleaved, it is immediately broken into its monomer, that is 2BH3 units. Okay, but at room temperature this diborane molecule is existing as a dimer, that is B2H6. Okay, so this is the structure and bonding of this diborane molecule, that is B2H6. Okay, so this is all about the boron hydride, its structure, bonding, and its MOT approach to explain the structure and bonding of diborane. Okay, thanks for watching this video. Have a nice day.